Hi, everybody, and welcome again to the Musical Innertube. I'm Don Rooney.
And I'm John Timpain.
Hurricane Isaias, not too long ago, ran all the way up the East Coast and dumped a lot of rain and a lot of flooding. And it is the earliest in recorded history, I think, that we have gotten to the letter I as we work our way through the alphabet. And somebody who knows a lot about that and who's going to tell us maybe why that's happening is Carl Parker, who is severe storms expert down at the Weather Channel. Good morning, Carl.
Good morning.
Carl, am I wrong in saying that we have a lot more hurricane activity in the last few years than we've had in the past?
Well, it's an interesting question. One thing that's definitely happening is we're seeing an earlier start to the season, and that has a lot to do with the amount of warmth that's in the oceans. The question of frequency in the longer term is a very, very muddy one. And I can tell you all about, what the climate science is saying about where we're going to be going with hurricanes. But in a very broad sense, there's a lot more warmth in the ocean, which means there's more potential energy for hurricanes. The temperature that is requisite for hurricanes to develop and maintain themselves is about 80 degrees, and that's because of the instability that exists at that temperature. So you've got warm ocean waters that's warming the air that's just above the ocean. And when it's at that warmth, then you tend to get enough instability to allow thunderstorms to develop and rise up through increasingly cooler air. It's not fixed. I mean, it can happen at lower temperatures, but generally that's what's required. And so what we're seeing is that we're getting to that level earlier. It's happening more broadly. Temperatures are much warmer than average all across the Atlantic basin. And so all other factors being equal, if you've got more warmth in the oceans, you're going to extend the goalposts a little bit. You're going to increase the length of the season. And then also there is this potential for storms to get even stronger.
Now, I had seen where the National Weather Service had extended their predictions. They're saying we're going to get 25 storms this year. Is that right?
Well, you can never say for sure. And the thing about predicting the number of storms is it often doesn't tell you that much about what a given season is going to do. For example, in 1995, we had a terrific number of storms, and there wasn't a whole lot of impact in the U.S. In 1992, we had relatively few storms, but of course, we had Hurricane Andrew. So while it is true if you have more storms, you might get more impact, it doesn't necessarily mean that. But what is disconcerting is that this year we're seeing very low wind shear. And, that is one of the thornier questions about the future. Like, where are we going to go from here? Well, we know that the oceans are taking on the vast majority of warming that's occurring. And so we know that, as I mentioned, all of the factors being equal, you increase the warmth of the oceans, you increase the maximum potential intensity. And so there have been some studies that suggest that we might see the MPI is thought now to be about 215 because that was the strongest tropical cyclone that we have seen in recorded history. That was Patricia back in 2015. And the thinking is that that may increase to about 235 by the end of the century based on that increase in temperatures, in sea surface temperatures. But, it's a very, very difficult thing to nail down because there are a lot of other factors that come into play. One is that, if the oceans are warming, is that also going to mean that the upper atmosphere over the oceans is warming concordantly? And if that's true, well, then maybe the instability doesn't increase that much or doesn't broadly, but can in some situations. And then there are also questions about what amount of wind shear we're going to be seeing in the future, what amount of Saharan dust is going to come out across the central Atlantic. So it's very, very difficult. And generally, if you look at the synthesis data, National Climate Assessment and the IPCC, what they're saying is that broadly, there may not be an increase in the frequency of storms, but we may see more of the most intense storms, and we may see that intensity level increasing. And another really important couple of trends is that we're seeing more rainfall. Generally, for every 1 degree Celsius of increase in temperature, you add about 4% more moisture to the atmosphere. The atmosphere's holding capacity increases. And then the other trend is that we are seeing a slowing of tropical cyclones worldwide. And that's been about 15 to 20% in the Western North Atlantic once they've made landfall. So when you combine those things, you combine more capacity to hold moisture, along with a slowing of the forward speed of tropical cyclones. The result is that you're going to get a lot more rain in a given location, which is precisely what happened with Harvey. Harvey would not have been what it was were it not for the fact that it stalled. The storm itself got really strong and it took a long time to spin down because it was close to the Gulf of Mexico. But the fact that it stopped for 2 days was what made that one of the greatest disasters in American history. And so those are really, really important trends. When you combine all those things, a likely increase in intensity, a likely increase in the amount of rainfall the storms produce, and a likely slowing of the forward speed, all of those things are going to serve to make tropical season more difficult in not just here, but everywhere around the world. The one thing that we really don't know for sure, though, is what will happen with the frequency of storms in a given year.
Hey, Carl, could you explain the significance of wind shear and the
Sure.
changes that you're seeing in it?
Yeah, so tropical cyclones they're really interesting entities. So it's a great big heat engine basically, and you have a disturbance, and these disturbances come off the coast of Africa, and you begin to get some thunderstorms developing about this disturbance. Well, as these thunderstorms develop and they take in warm and humid air, there's condensation, and that process releases latent heat. And in the release of latent heat, this central area where these thunderstorms are developing develops a lower pressure because warmth is equivalent to density. And so with warmer conditions, you have a lower density, so the air is rising even more, pulling in more warm and humid air, and there's more convergence. And as the air converges, it has to rise. So all the way around, this engine becomes more efficient, taking in warm and humid air, rising up through thunderstorms, releasing latent heat, and fueling the development of an ever stronger area of low pressure. But in order for this engine to work properly, it has to be what we call vertically stacked, where
Hmm.
you have this inflow of warm and humid air near the base of the storm, and then it rises up through the towers of the storms in the middle of the storm, and then comes out at the top and spreads out nicely in all directions. Well, if you introduce strong winds into that environment, first of all, you change that vertical stacking. You can tilt the storm over, which is, by the way, what we saw with Isaias. It was very tilted for a long time, which was part of why it didn't get real strong as it was sitting off the Florida coast. So wind shear interrupts that process and can also inject drier air into the system, which also defeats the development of thunderstorms. So generally speaking, tropical cyclones develop in a very light wind environment. That's what they favor, and as long as you've got that and you've got warm ocean temperatures, you've got the ability for the storm to continue to strengthen or maintain itself.
Like you said, that the forward progress is slowing. That was certainly true of Isais and some of the others.
Hmm.
The recent one we had down in Texas as well, off the Gulf Coast. They don't seem to be generating enough. Although Isais was very fast moving, it didn't have a lot of wind associated with it. It was mostly water, mostly the rain.
Yeah, well, there were actually, quite a few reports of wind damage, through a lot of the mid Atlantic to Northeast coastal area. So anywhere from, say, eastern North Carolina and Virginia up into New England. We did have a lot of trees down, a lot of power lines down, that type of thing. Um, it is a little early yet, and there are still a lot of mousetraps. If you look at the average distribution of wind shear in the Atlantic basin, it's continuing to decline, and it reaches its bottom, essentially, the base of that trough in the graph reaches that in September, which is exactly why we see this peak of hurricane activity in September, because everything else is in place. You've got warm ocean waters, but the wind shear drops off quite a bit. Now, we've had unusually low wind shear just in the last month or so. And, this storm that we just saw, Isaias, faced a number of difficulties. It was interacting with wind shear, was interacting with some drier air. Um, so, this is why we say all other factors being equal with respect to sea surface temperatures, because if everything is ideal, and you've got warm ocean waters, that's when you can see the storms take off. And that's when you see a lot more of a wind threat. But, it's often true that you don't see ideal conditions. It's often true, especially as storms get closer to the U.S. coast. they start to interact with this continental air, which is drier. And, there are a lot of different places in the Atlantic basin where you have a little more wind shear. That's certainly true in the Eastern Caribbean. That can be true across parts of the Northern Caribbean. So, it's just one of those situations where, and again, mentioning there could be a lot of storms this year, there could be a lot of storms, but whether or not they turn into something really horrific and whether or not they have an impact on land in the U.S., that's kind of the wild card in these forecasts. And nobody can really know that.
It's what everybody wants to know, too.
Yeah, well, exactly. Exactly right. It's just really, really important to remember that, if you think back to 1992, our first storm was Andrew, and that occurred in late August. So practically nothing happened prior to that. And, then it ended up being one of the worst storms in American history. And then the opposite can also be true. You can have a whole lot of storms. And if you have, for example, a persistent trough of low pressure along the East Coast, then that can oftentimes just grab them around, recurve them, as we say, and then maybe one slips under and gets into the Gulf, but many of them will just go up into the North Atlantic and recurve.
I've been worried that maybe we're being very subjective, me and my friends and family living where we do, which is New Jersey. But
Mhm.
in the last 10 years, especially, we've had a lot of, dinner time conversations about how the storms are getting more intense and we're seeing crazier things than we used to in terms
Yeah.
of, I don't know, high winds. And there's been an awful lot more damage in our area in a given year than before. I'm just wondering, can you comment on that? I mean, I had mentioned that you had mentioned that there is the potential for increased intensity in storms.
Yeah. Well, this is really difficult with respect to observation. So it's very well known in climate modeling that if you increase the amount of warmth in the oceans and you increase the potential intensity, that you're going to see the thermodynamic lid raised, and you'll see storms getting stronger. What is really, really hard to do is to detect a signal, a climate change signal, because the record of tropical cyclones is very noisy and it's very short. We've got an excellent record of storms over the last few decades, but then you go back a little farther than that, and there are some holes, and it's not quite perfect. And the instrumentation was not as good. You go back farther than that. I mean, you go back prior to the satellite era. Well, there must have been things that we missed out there, and you can go back to a time, in the early 20th century when they were out looking at hurricanes and just kind of eyeballing things. I mean, when they were first starting to fly storms, and that would have been just prior to the satellite era, they actually would look down at the sea surface. And this is actually a really good way to determine what the wind speed is, because there's a device on Hurricane Hunter planes called the Step Frequency Microwave Radiometer, SFMR. And what it does is it scans the ocean surface and it sees where the sea spray has been kicked up because of the wave action, because of the winds, and that sea spray emits some radiation, and this device detects that. And it turns out it's really accurate. It's generally accurate to within 10%. But this is a device that's doing this now. And back in the early era of the hurricane hunters, just prior to the satellite era, there were guys who were flying into these storms who were actually looking out the window and looking at the state of the sea and making a subjective determination about how strong the wind was. So, in no way is that comparable to the instrumentation that we have today, which is why that we say that the record of tropical cyclones is noisy and it's short. When that's why we can't say definitively, oh yes, these storms that are occurring right now are absolutely stronger than they've ever been. That having been said, there is a lot of compelling circumstantial evidence. I mean, you've seen a lot of records being set. As I mentioned, you had the, you know, uh, strongest tropical cyclone in world history in Patricia in 2015, and then a number of other storms that were way, way up there. Dorian was tied for the strongest at landfall in Western North America by wind speed. You had Irma, which I think spent 37 hours or some crazy number like that at 180 or 187 or 185 miles per hour. So, there are a lot of cases where we're seeing not just amazing intensities, but also a length to this intensity, storms staying at a very high state for a long period of time and what appears to be longer than what we have seen in the record. But scientifically, science is that's a funny thing about science and climate science is really conservative. And, people who do this for a living, who research storms and climate, they don't want to go out on a limb and say something that could be overturned. So they're really, really careful about what they want to say. And so there is this limiting factor of how much we've known for how long. All of that being said, though, it's definitely pointing that way. It definitely looks like storms are getting stronger, wind conditions are right. And, that's a big, big deal because if you've got, storms, if that limit, that lid is being raised every year, if you're going from, 215 to 220 to 225, with gusts getting to 240 or 245 or 250, well, you're talking about winds that are along the intensity of strong tornadoes. And, but not just, in a limited area the way a tornado is, but rather in an area that could be, miles or even tens of miles wide. So, you're talking about really complete destruction. That's what happened with Charlie, by the way. When Charlie came into Florida, it was kind of a glorified tornado. I mean, it was just a really intense, very tiny relative to hurricanes inner core, but the damage that it caused was very much like a tornado, and they didn't know exactly how to handle that at the time. We didn't have this new product called the extreme wind warning. So what the Melbourne office did was something very smart. What they actually did was issue tornado warnings all along the path of the storm as it came up through central Florida, because they were expecting tornado-like wind to occur in those areas. And of course, in that level of wind, you're going to have, a terrific amount of destruction, structural and otherwise. And so that, I think, is going to be a risk, certainly going forward, that will increase. And it's not going to be happening all the time, probably, because again, conditions have to be just right. But certainly there's going to be more of this threat for really intense hurricanes.
Two things that occur to me is, number one, we had a relatively mild winter, at least here in the Northeast this
Yeah.
last year. Could that contribute to it? And second of all, we'll get to the Big Bang. We'll get to the global warming. What is
Yeah.
that having an effect on it?
Yeah. Well, I think, all the way around, seeing less of these really profound cold outbreaks, the aggregate of seeing mild winters and warmer summers, all of that is contributing. But the oceans are taking on more than 90% of the warming that has occurred in the earth over the last several decades. And so, that's where global warming is going, into the oceans. And it's frightening, to be honest with you, because that heat energy is stored. It takes a long time for oceans to warm up, and it takes a long time for them to cool off. And as we're seeing more warmth, not just at the surface, but to greater and greater depths, that too is really, really important. That's important with respect to hurricane intensity, because what we've seen a lot of in the past is something called upwelling, where you have a layer of warm water that is, sufficient for the maintenance of a tropical cyclones. And then underneath that, the water gets slightly cooler. So when the storm gets really strong, it starts to churn up the water and it brings up that cooler water from below. And that serves to weaken that heat engine. Well, if the water is nothing but warm as you go down and down and down and down, and in the case of Typhoon Haiyan, which hit the Philippines in 2013, it was the strongest at landfall in world history, 195 miles per hour. Um, when you looked at the water profile right before it made landfall, there was water that was warm enough, 80 degrees plus, that extended down for a depth of a football field. So it's a limitless supply of warmth in that case. No matter how much the water gets churned up, it's just more and more energy coming up and creating that flux, bringing that heat from the ocean into the air, and going on to power the hurricane. So yeah, there's just going to be more and more warmth in the ocean, and that's going to be even when we have cold outbreaks, that knocks that back a little bit. It's a longer term thing.
What about the La Nina and the El Nino cycles out in the
Mm.
Pacific? And I've had many people tell me or ask me, why does what goes on in the Pacific affect Atlantic hurricanes?
Yeah. Well, it depends on, right. It depends on where you are. El Nino is an abnormal warming of the equatorial waters of the Pacific. It's got a couple of different phases, so it can happen in the Eastern Pacific and in the Western Pacific. But generally, broadly, what happens in an El Nino year is it gets warm in the Pacific, which makes it more possible to see strong hurricanes in the Pacific and perhaps around Hawaii. Although very small target there, it's very hard to actually have one go right over one of those islands. Um, and what also happens is it changes the upper level wind flow such that there tends to be more wind shear across the Western North Atlantic.
Hmm.
Now, that doesn't always happen that way. These types of things are very broad, and there's a lot of other stuff that's superimposed on that, but that's generally what happens. And in the case of La Nina, it tends to be the opposite of that, where we have less wind shear across the Atlantic basin. And so we typically do get more hurricane activity in the Atlantic basin.
That's amazing. It's sort of a party question I now have the answer to.
Let's talk about the importance of meteorology in everyday life. You and I were talking before we went on the air, Carl, and it seems like weather forecasting is a bigger and bigger part of local newscasts now. Some newscasts locally even lead with the weather.
Well, I think it's a necessary thing. My sort of cynical joke about climate change is that it's a growth industry. The fact is the weather is getting wilder all the time, because you've got this increase in moisture in the atmosphere. You're going to be looking at more potential for flooding, not just in tropical cyclones, but in, more sort of run of the mill events with thunderstorms, with, just regular mid latitude traveling cyclones, as we call them, storms that come across the country. This potential for flooding is going to increase. But the irony is that we're seeing more broadly an amplification of this water cycle on both ends. So when you've got heating that occurs over the oceans, that evaporates moisture from the oceans more readily. And the result is that you get more moisture in the atmosphere. And as I mentioned earlier, the atmosphere, when it's warmer, has more capacity to hold moisture. So those two things work together to put more moisture into the air. And so when conditions are right, you tend to get very heavy rain and flooding. But the opposite is true over land. Increased heating means more evaporation over land. And while the oceans hold the vast majority of the water on Earth, uh, the land holds only a very, very tiny percentage of it. So it's not that hard to get all the water out of the land. And so when the pattern sets up where you've got very hot conditions and it goes on for a long period of time, we're seeing droughts occur more quickly and there's a greater depth to that drought. And so when you look at a place like Texas where they can flip back and forth very quickly from flooding to drought because they're sitting next to the Gulf, but also next to the desert, they can have these really rapid swings between drought and flooding. And it's putting a lot of pressure on farmers. And what's funny about that is that farmers were among the groups that were more resistant to, hearing about the changing climate. And now their attitudes are changing very quickly because, you've got people that know the land, they've been working it for decades, and they're simply saying, this is not familiar. This is not what we're used to dealing with. And I think that's one of the things that I've heard over and over and over again with respect to flooding, with respect to, say living along a creek or along a river, people saying things like, I've been here all my life and I've never seen anything like this before. So I think that people are intuitively on a gut level aware that the atmosphere is changing. The way the atmosphere works is changing. And the simplest explanation, of course, is that we're heating the planet.
Yeah, it's sort of comforting in a way what you just said. We
Mhm.
live in the weather, don't we? From day to
Yeah.
day, and it can creep on us that things are getting different, right? Over a series of years, if you live in one place.
Yeah, absolutely. I mean, I've seen this over and over again. And, so I do think that people are becoming more receptive to this. Polling on this question is really interesting because consistently, if you look at, for example, Pew polls, they're really good about this. What they do is they ask people about their attitudes about climate change. And so generally speaking, it's about 6 to 7 in 10 Americans think that it's happening. Maybe a point less think that we are responsible for it. So, you have this faction that's sort of holding out and not really embracing the idea of climate change. But then when you ask people whether they support fossil fuels, support for that is really waning. I mean, it's oftentimes in the 40s. And if you ask them if they support renewable energy like wind and solar, it's solidly in the 80s and up to about 90%. And I'm not really sure what the disconnect is there. I mean, I know that just in general, it seems like a better idea because, you don't have the pollution and what have you. But it also seems like it might be sort of a backhanded admission. Like we don't want to go as far as to say as, maybe this is a climate thing, but why not? Let's go ahead and move in that direction. And so I do think that people are aware that the planet is changing, even at a local level, apart from what they're seeing on TV and what have you. And I do think that attitudes are changing. And I really hope, I've been doing this climate presentation for a long time now, and it's been a great opportunity. I've actually really missed it in the last 5 months because I often talk to school groups and other groups, and it's just great to have that interaction and to have people ask you questions and that kind of thing. And one of my favorite stats from the whole presentation is that the amount of energy that the whole world needs, and this was calculated a few years ago, so it might be a little different now, but the amount of energy the entire world needs on a constant basis is 18 terawatts, a terawatt being a trillion watts. So as long as we can get 18 terawatts, we'll have all the energy that we need. And the sun gives us at the top of the atmosphere 173,000 terawatts every moment of every day when you're facing the sun, of course. Um, so I mean, it's so fixable. It's such an incredibly fixable problem. It's not for lack of an alternative. It's not because we don't have the technology. It's not because we couldn't, you know, find a way to implement those things and create some sort of a moonshot and do that. Which, by the way, would probably be fantastic for the economy to transform the way you get energy and the way you use it. It's not for any of those things. It's because we have a system that is being held with a very tight grip by these old world interests. And that's the shame of it. That's really the shame of it. But I do think, there are a couple of important trends. One is that people are starting to think differently about it. The other really important trend is that the markets are going to dictate this. And if you sit and think about this for a moment, think about all of what goes into a coal-fired power plant, all the technology, all the mechanics. There's a lot. There's a lot of stuff. I mean, you're talking about, you know, I don't know what the exact cost of a power plant is these days, but it's not cheap, of course. And then you compare that to filling a field or a farm with solar panels, where you put the solar panels in, they're fixed, and that's the end of it. That's all you do. You check on them once in a while. You have some maintenance to do here and there, but you don't have all these moving parts. So the capital cost of installing new solar energy is actually cheaper than the cost of maintaining coal plants. And that's, worldwide, increasingly so here in the US. And so, once it's a market-based thing, once it no longer makes financial sense to stay in dirty fuels, well, then it's going to be a relatively rapid transition, unless there are efforts to stymie that. And that's part of what's going on right now. But I do think there are a lot of encouraging trends, in a lot of ways we're moving in the right direction.
Do you think then that since the ground level attitudes of people from farmers to people who live near rivers and are seeing 100-year events every other year from, is from flooding and so forth, if they're changing and the economics will dictate that corporations change after they see the problems with the economics of it all, is there a possibility that down the road we're going to make a gradual, maybe a 5, 10, 15-year transition to renewable energy?
Yeah, I think it's inevitable. I mean, I think we're all going that way. I mean, it's it's sort of amazing, for example, I can think of one really personal example. My wife and I got a couple of Honda hybrids, and they're not real small cars. They're pretty good sized vehicles, and they're comfortable. And one thing I've noticed is when I rent a car now that has a regular full size combustion engine, the car shakes. And that might seem like kind of a small thing, but it's big once you're used to it. Once you're used to the idea of, you're at a light and you hit the accelerator and there's no sound and you just smoothly accelerate. Um, Once you've gotten used to that, you come to really enjoy it and appreciate it. And so I think that's a metaphor for a lot of things. I think in a lot of ways, we're moving there. It's inevitable. That's where we're going to be in the future. The problem now is the speed with which we do it. How quickly are we going to do it? Because we're really out of time right now. We're starting to see these incredible, amounts of ice loss in the Arctic and the Antarctic. There are so many wild cards there. I mean, you could have some enormous ice sheet give way. And, the way that it's sort of set up, especially in the West Antarctic, is you have these, sort of linchpins, these, critical inflection points, if you will, where if you let one part go, maybe more follows, and then it lets the whole thing out. And so, I don't think that it's inconceivable that we could see a sort of rapid rise in sea level, for example, if a significant part of one of these ice sheets were to give way. And we're toying with that now. We're right on the edge of, you ask the top scientists in the field, and they'll tell you, well, we don't really know. We don't know if it's decades from now. We don't know if it's well over 100 years. We don't know if it's 5 or 10 years from now that we'll see some parts of this ice sheet give way. So, we're really performing a vast experiment, and the cost of sea level rise alone is going to be staggering. There have been some papers that have suggested that it could be as much as 10% of GDP, which it's hard to even wrap your mind around that. I mean, the cost of climate mitigation is thought to be about 1 to 2% of GDP, maybe more in some cases. But, 1 of every $10 going towards that. And then just think of the loss. I mean, not just the financial loss, and you get trillions and trillions of dollars of property sitting at 6 feet of elevation or less, but not just that, but also just the emotional loss. I mean, places that you've known all your life, gradually changing, hopefully continually gradually changing. But, there's just so much cost to these changes. And what we really ought to be doing is, we need more effective leadership on this point at every level of government, and we need to move rapidly to this new way of doing things. And that's happening in a lot of countries. I mean, it's amazing the progress that we've seen in Europe and in a lot of different places. We are getting there, but we're not doing it quickly enough. And I think with the proper incentives, I think we could do it relatively quickly. I mean, I think it's entirely possible for us to just transform the way that we do things. And that doesn't mean that everybody has to get on buses and everything like that. I mean, you start, doing what Tesla did, and you start mass producing cars like that, and you start powering these vehicles with more clean energy because it's cheaper. You're going to see this quick movement, on a historical decadal scale. But what we really need is for it to happen even faster than that.
I've seen all sorts of things about X number of years. Miami will be underwater X number of years. New York will lose some streets and that sort of thing. What are we talking about? You're talking decades to change over, but that's not enough time to reverse situations like that.
Well, I think that the unfortunate truth is that it's probably going to be wrenching in coming decades for a lot of these coastal areas. There's a stock flow principle in climate science, and what that is essentially is that every year we're putting additional carbon into the atmosphere. So that you can think of as a faucet, a bathtub faucet that is running. And as the bathtub is increasingly more full, that is the total amount of carbon that resides in the atmosphere. And some of that drains off. There are some natural carbon sinks, including the ocean, that take care of a fair amount of that. But the bathtub is still very much full at this point. So even if we can reduce that flow out of the faucet to a trickle, we've still got the problem of all the water that's in the bathtub, and we need to drain that a lot more rapidly. So essentially what that means is that a certain amount of climate change, global warming is baked in. It's going to happen no matter what, no matter how quickly we can ramp these things up. There are some promising technologies in terms of negative emissions. Trees, fantastic example of that. If we can plant millions or even billions of trees, that would certainly help. There are actually technologies that can suck carbon out of the air, but still tricky. They're still working on a way to make sure that that's energy efficient, because if it's not, then it defeats the purpose. So there are going to be ways to try to draw down these emissions over time, but it's going to take a long time. And, because this is such an enormous system that we have altered here, a certain amount of these things are going to occur. Now, in a place like Florida, it's going to be very, very hard because they've got porous soils down there, porous bedrock, and that's going to allow the water to come in no matter what. You cannot build a wall in South Florida to keep that water out. So the first thing that's going to happen is it's going to affect the water supply down there. And then it's going to start to affect these coastal areas. I mean, we're seeing that already. We're seeing these king tide days where you've got water on the streets in South Miami. That's only going to continue in that direction. In other parts of the country, we will be able to use some combination of managed retreat and also barriers. New York City, for example, because they've got more solid bedrock, they can use barriers to keep the water out. They've got other issues, though. I think they've got something like 4,000 openings citywide, where water can come in through these subterranean tunnels and find its way in that way. So, there's a lot of different things that will have to be done, but there are some places that will be able to handle it more effectively. But, unfortunately, Florida is one of those spots where I think it's going to be really, really difficult. And I just get I actually have family in Florida. We go down to Juno Beach quite often, and I just love the beach down there. I just absolutely adore the beach. And that's, I think, one of the things that makes me a little sadder about all of this is just thinking about, what could be lost. I mean, if you think about some of these places that have meant a lot to you, that meant a lot to you and your family, that could mean a lot to your kids in the future, what will they be like? What exactly is it going to look like in the future? And I think that's, a part of climate change, apart from all the other, the huge economic loss potentially and all of that. There's this emotional cost as well that I think is not discussed often enough. And I think it could be really significant for a lot of people.
And I'm sure that eventually we'll all turn this stuff around, and you and I will not have to do our next interview on boats.
Yeah, right.
But thanks for being with us today, Carl.
Thank you for having me. I appreciate it.
All the best.
And thank you for listening to the Musical Innertube. If you'd like to get in touch with us, our email address is musicalinnertube, all one word, @gmail.com. We're also on Twitter, @JTimPayne and @DonRooney9. We're on Facebook, Apple iTunes, YouTube, Stitcher, SoundCloud, Spotify, iHeart Podcasts. Feel free to like us and give us a good review on any of those platforms. Our webpage is Musical Innertube. That's musical spelled with 2 A's, MUSICAAL, Innertube, all one word, .libsyn, spelled LIBSYN.com. And thanks, as always, to the virtual band Car Radio Dog for providing our theme music.